is lecture video 29, and we will be talking about antiderivatives in this video. So far, we have studied how to find derivative of a function. However, many problems require that we recover the function f of x from its non-derivative, where we denote here with the big letter F. Okay, so we will see in the next chapter that antiderivatives are the link connecting the two major elements of calculus, derivatives and definite integrals. What I mean is, soon we will be calling the antiderivatives as the integrals of functions. This is a nice introduction to the integral topic. Okay, so what is an antiderivative? It is already defined here as an antiderivative of an f is a function like this for all x in the domain. So if you have a function, big letter f, whose derivative gives you your function, then this big letter f function is called the antiderivative of your function f, okay? For example, what is the antiderivative of 3x squared? So f of x is 3x squared, and we search for the antiderivative, big letter f of x for it. So you should tell me now a function, big letter f, whose derivative is 3x squared. So of course it will be something like this, and you may add different constants to here, like +1, -2, +100, and so on. So all those functions satisfies this equality, like derivative of x cubed +1 or this one or this one. If you derivate them, you will always, derivate them, you will always get 3x squared because constants are gone in derivation. And that's why we will denote the general antiderivative function by writing an arbitrary constant here. So to denote all these constants, we can just write +c, where c is an arbitrary constant. Okay, and here, if the antiderivative function is written with an arbitrary constant, it is called the general antiderivative function. Okay, so and in this graph, you can see the graphs of the general antiderivative functions with different choices of the constant c, okay? And here, if you take the derivative of this big letter f, it is 3x squared as desired. Like the derivative of this big letter f, it gives us the original function. Okay, so if f is an antiderivative, the most general antiderivative function is denoted like this. We already mentioned about that. Example, this time our function is f of x equals cosine 2x, and I want to search for the general antiderivative function of it. So tell me a function whose derivative is cosine 2x. Okay, what should be that function? Maybe we can put a small recall here. Derivative of sine 2x is in fact cosine 2x times 2 because of the derivative of the insider part. That's why if you want to get rid of this extra constant 2, which is the case here, you need to put a 1/2 in front of your function so that this 2 is gone, right? So that you have just cosine 2x in your derivative. That's why antiderivative function is, of course, sine 2x, but to get rid of this extra constant here, you need to put 1/2 in front and also plus an arbitrary constant. So if you derive this expression, you will exactly find this one because constants will be gone after you take the derivative, right? So this is the verification. If you take the derivative, you obtain exactly cosine x, which is our original function. Okay, let's do the same for this one. We want to search for the antiderivative function. So tell me a function whose derivative is this one. To find the antiderivative of the given function, you need to consider like that. Okay, so maybe another recall. Derivative of 3 to the power x. This has a special rule. Itself times ln 3. Now, I want to write here a function whose derivative is just 3 to the power x. That's why, to get rid of this extra constant ln 3, I need to multiply this function with 1 over ln 3 so that the derivative will become exactly 3 to the power x. So 1 over ln 3 times 3 to the power x is the antiderivative of this component. So you can check that by taking the derivative of this expression, which is exactly this one. And what about the second component? So this expression is in fact a power expression like this. How do you take the derivatives of power functions? So what is the derivative of this power function? You take the power down, you subtract 1 from the power. And what I want is, I want to find a function here whose derivative is exactly this power. So how can I get rid of this extra coefficient in front to obtain just x to the power n? Of course, I need to divide by it here so that I can get rid of that extra coefficient and just obtain x to the power n. So this is the rule. If you want to obtain x to the power n after taking derivative, you need to write this expression. The rule is, what is n here? N is minus 1/3, right? So you add 1 to the power. So add 1 to the power, it becomes this, divide by the same power. So now you can easily check by taking the derivative of this expression if it is this one or not. So obviously, if you take the derivative of this expression with respect to x, you will exactly find this. So antiderivative of this power function is this one coming from this computation. Okay, and of course, at the end, you will add an arbitrary constant c to find the general antiderivative function. Okay, so next exercise. F of x is like that. We want to find the general antiderivative function of it. So tell me something, some function whose derivative is this one. So recall again. Do you remember a function whose derivative is secant square? Derivative of tangent is secant square of x, right? So I should start by writing, of course, tangent of 3x over 2, but derivative of this expression will give you an extra 3 over 2 in front, right? That's why to get rid of it, I will multiply it with 2 over 3. Now, of course, there should also be minus as we have here. So if you take the derivative of this expression now, you can verify that you will exactly find the given f of x. And now I can add my arbitrary constant c to give the general antiderivative function, okay? So let's move on. Find the function with the derivative to the power e to the power 2x whose graph passes through this point. So I want to find a function f whose derivative is this one. So f of x should be what? And at this point, we remember that the derivative of the exponential function is itself. That's why the original function should consist of e to the power 2x. But if I derivate e to the power 2x, okay, let's put a very quick recall here. If I derivate e to the power 2x, I will have an extra constant 2 coming from the derivative of the power part, but I don't need it here. That's why I need to multiply 1/2 to get rid of that extra constant there. Okay, so if you derivate this now, you will exactly find 2 to the power x, but of course, an arbitrary constant should follow. And to find this arbitrary constant, what is this? Find this arbitrary constant by using the initial point, by using this initial point, okay? So it means that this function passes through this point where x is 0 and y is 2/3. If you insert these two things to your equation, e to the power 2 times 0 plus c, you will exactly find c as, I guess 1/2, no, 1, just 1, yeah, 1. So this gives you the antiderivative function passing exactly through this point. If you choose the constant as 1, then it will pass through exactly the given point there. Okay, so like this. And here you will see a table of antiderivative functions for the most popular ones. So power function, its antiderivative is add 1 to the power divided by the same power. If you have sine kx, of course, minus cosine x will be its antiderivative, but to get rid of an extra k coefficient in front, you need to multiply with 1/k and so on. So these are the most commonly used functions, and over on this column, you will see the general antiderivative rules. And soon we will be calling the general antiderivative as the integral next week, okay? So two more things. Taking antiderivative respects arbitrary constants. So if you take the antiderivative of this expression, k goes out, so the antiderivative of small f function is the big F function plus c, and it also respects addition and multiplication. So fg corresponding antiderivatives directly respects summation and addition. Okay, as the last example of today, we will find the general antiderivative function for f given here. So we are searching for big letter f, which is the antiderivative of the given function f. Okay, tell me a function whose derivative is this expression, okay? We will always be thinking like this. Okay, so let's rewrite f as, okay, so I will rewrite f as 3 times x to the power minus 1/2 plus sine 2x. Okay, now tell me a function whose derivative is this expression. We know how to find antiderivatives for power functions. Add 1 to the power, divide by the same power. So I am adding 1 to the power, dividing by the same power. So let me just write in details. Minus 1/2 plus 1 divided by the same power, minus 1/2 plus 1. 3 is just there. You see, constants are not affected by taking antiderivatives. Plus, tell me the antiderivative for sine x, sine 2x. It is obviously cosine 2x, but just to get rid of the minus cosine 2x, of course, get rid of the extra 2 coefficient, you will put minus 1/2. Minus cosine 2x. It is also given here, you see. So the antiderivative function is 3 times x to the power 1/2 divided by the same, I add 1 to the power, divide by the same power, plus minus cosine 2x over 2. Of course, we are searching for the general antiderivative function, so we need to add an arbitrary constant c at the end. And if you want to verify this, if you take the derivative, you will end up with the original function again. Okay, this will be the verification for you. So that's all. Thank you for your attention.